Hello everyone. In this video, we will talk about a new topic, false position method. The false position method is a modification on the bisection method. The false position method and the bisection method are very similar. Actually, both of them belong to the bracketing method. This is because both of them start with a initial bound a to b, which brackets the root. So the problem we want to solve is that given a function of one variable fx, we want to find a value r such that fr is equal to 0, which is a root finding problem. The assumption is the same with the assumption we used in the bisection method. We assume that fx is continuous. The initial requirement is also the same with the initial requirement we used in the bisection method. We have an initial bound a to b on the root, that is fa and fb have opposite signs. The iteration process is a little bit different from the bisection method. Let me explain to you. Assume that we have a function from a to b. So this is fa. This is fb. Fa and fb have opposite signs. And if you use bisection method, when you do the iteration, you need to find the midpoint of this interval, which is a plus b over 2, right? However, when you use false position method, instead of using the midpoint, we draw a straight line connecting the points a, fa, and BFB. And this straight line will have an intersection point with the x-axis, and this point is the C. Then we can examine the value of FC to see if FA and FC have opposite signs, right? So in this case, FA and FC are both negative, and FC and FB have opposite signs. So then we can we are sure that the root is located in the interval from C to B. Then we can remove the interval A to C, and the C will be the new variable A, right? So in the next iteration, we will focus on this interval. All right. So this is the difference between the false position and the bisection method. So my question is how to represent this point C mathematically. In order to find the formula for the point C, we can draw a triangle here, right? And another triangle, another triangle here, right? So these two triangles are similar because the angle, this angle equal to this angle, and this angle equal to this angle. So as a result, this length, so this length over this length should be equal to this length over this length, right? Because of the similarity of the two triangles. So let's see what's the value of this length, right? It should be C minus A, and the value of this length should be B minus C. This should be equal to this length here, which is FA, the absolute value of FA, over this length, the absolute value of FB, right? And because FA and FB have opposite signs, so one of them must be negative. So if we want to compare the length should be positive, right? So actually, this should be negative FA over FB because we want to have a positive value for the ratio of the two lengths. All right, and then you can multiply FB on both sides. So this will be C minus A over B minus C times FB equal to negative FA. And then we can multiply B minus C on both sides. So C minus A FB equal to negative B minus C times FA, right? Then we can move those terms, like the one with C, so we can move the one with C to the right hand side. So CFB minus CFA equal to AFB minus BFA, right? So as a result, this gives you C equal to AFB minus BFA over FB minus FA. Okay, so this is the point C. If you cannot memorize this formula, so at least you need to know how to derive it, right? So this is the formula for point C. Okay. And after you find this point C, then there are 3 different scenarios. The first one is that C happens to be the root. This is very unlikely in practice, but it's possible, right? So if that happens, then we stop the iteration process because we already found the root. And another scenario is that if FC and FA have opposite signs, then the root must be in the interval A to C. So we can assign B minus C to a variable called step, and then assign the value of C to the variable B. So let me explain this to you. For example, we have a function from interval A to B. The function looks like this, and then this is FA, this is FB. So we draw a straight line connecting these 2 points, right? And then the intersection point with the x-axis is called C. So we compare the value of FC with FA and FB. So you can see both FC and FB in this case are positive, but FA is negative, right? So FC and FA have opposite signs, right? Then the root must be in the interval from A to C. Then we can remove the C to B interval, right? So in the next iteration, we will start from this interval. This interval will be the new A to B, right? So we need to assign the value of C to the variable B, right? Because this point will be the new B for the next iteration, right? And then when you start the next iteration, you can again draw a straight line connecting AFA and BFB, and then find another C, which is the intersection point. And then you can do this over and over again. All right? So the last scenario is that FC and FB have opposite signs, and then the root must lie on the interval C to B. So then we can assign C to C minus A as a variable called step, and then assign C to A, right? So let me show you the next scenario. So for example, we have a function from A to B. The function looks like this, right? And this is the FA. So this is the FB. To find the point C, we connect AFA to the point BFB. And then there is an intersection point with the x-axis, which is C, right? So we can evaluate the function value at the point C, FC. So in this case, you can see FA and FC are both negative, right? But FC and FB have opposite signs, right? So if this happens, we know that the root must be in the interval from C to B, right? And then we can remove this interval A to C. And in the next iteration, this interval will be the new A to B. So this one will be called A, this one will be B. So that's why we assign the value of C to the variable A. So this C will be the new A. Okay, and then when you start the next interval, you have this one will be AXA, this is BXB. You can draw another straight line, find the intersection point C, as you did in the last iteration. You can do this over and over again. So this is the scenario 2, and this is the scenario 3. So let me explain a new concept, which is step here. So in scenario 2, step is equal to B minus C. So let's see, B minus C is the length of this part, right? Is like, initially we have the interval A to B, right? After the iteration, the A to B is shrunk to here. And the length, like how much it shrinks, this is called a step, okay? So this step is equal to B minus C. And in this one, initially we have interval A to B, right? After the iteration, the A to B shrunk to here. So this length here is like how much we removed from the original interval, and this length is called a step. So this step in the third scenario is defined as C minus A, right? So this step is how much it shrinks. All right, so I hope you understand this method right now, and in the next video we will talk about the halting condition, and I will show you an example about how to use false position method to find the root.